So, distinguished Vice Director for the Research, distinguished Dean, and distinguished audience, I'm very proud of being here presenting my research topic. So, my research topic is about software architecture. And if I want to discuss about what is software architecture, we need to think about traditional architecture. So, what's the difference between a dog house or a small chilled house like Leikimoki in Finnish and opera house or a big skyscraper? Well, there is a different structure, there is a different architecture. And when we talk about software, we do have the same problems. So it's not just about how to structure the software, but it's also how can we develop that software or that building in a reasonable amount of time. We can't take like the Egyptians, we can't take ages. We need to finish on time. So we have only a few amount of months. So what can we do? We put more people. And if we put more people, try to imagine renovating this room. You want to renovate quickly. You hire 2 persons and they can make it maybe in a week. Then you want to do it in a day. So instead of in a week, let's do it let's hire 20 persons all together in this room. They might make it probably faster. Let's hire 100 persons. Will they do it in an hour? No, they will just try to find a way to work together to stay 100 people in the same room. So when we develop software, we need to find a way to decompose our software in different sub-tasks. And that's what we are trying to do with software architecture. So in my research, we try to decompose existing system into some subsystem and some subcomponents that can be developed individually. So in this case, we can hire someone just to make the floors and someone to build the tiles. The tiles will be built somewhere else. So we are not building tiles here in this building. We build the tile in another factory, and then we bring them here. We try to componentize. We try to completely separate the different tasks, the different aspects of the software development. And when we do it, how do we organize the different teams? How do we split the teams? How do I understand if, for example, the team who is building the tiles, is it in the right place? Is it maybe a person who's building the tile working here, a person working there, and maybe someone else building this kind of very nice sign, University of Oulu, building together with the one of the tiles, so they're like clashing. They have this kind of coupling. So I need to wait as the tiles are finished before I can install University of Oulu sign. Can you imagine just arriving with University of Oulu when here is completely dismantled? It doesn't work. So that's when we do the software. So we need to try to organize the work, decompose in different parts, and synchronize them. And for that way, we are developing methods for decomposing an existing legacy, very old system into some new modern and componentized system based on individual services. We try to understand how we can have different people working together in the same services and how to avoid that they are clashing when they are working on the same research topic. So in that way, we are more efficient. We produce system of higher quality, and then we can have also a system that is cheaper to maintain in the future. But okay, fine. We created this new system. It's made. How do we know if it is good or bad? So the second area of my research is about measuring the quality of what we actually migrated to this new type of architectures. I mean, I can present this room for you, newly renovated. How do you know if it's good or bad? It looks nice, fine, cool. Yeah, it might be very good at the first glance. But is this room going to be maintainable? Are the cleaning personnel maybe spending 3 hours every day because the floor maybe is too sticky and it's not meant for being cleaned properly? Or maybe the glass are not properly isolated. So for the buildings, it's easy. Why? Because we have thousands of years of history in building construction and maintenance. But in software, we don't have thousands of years. We started in the 60s. So we have around 60 years of history. And now what we are doing is to try to follow traditional engineering, developer measures and metrics to understand if a new architecture is good or not. So we develop those metrics for coupling, for cohesion, for what we call anti-patterns, so different type of practices that should be avoided when we develop software. And after we identify what is the software quality, now, AI is coming in this world. We can't, of course, skip AI. Who am I just to forget using AI? So now we are trying to use AI and generative AI. So can we use AI to automatically optimize the architecture so as to optimize both those quality measures that we define, and some other researchers, of course, defined, and can we try to optimize the architecture to be more maintainable, or more usable, or better suitable for the final goal. So that's in a nutshell the research topics that I'm developing. Of course, it's not me, but it's all the work of my research team, my research lab. This wouldn't be possible, of course, without all of them. I'm just the one who is giving or helping shaping their ideas, and not actually the one who is developing. Thank you.